Today we're going to be covering rational functions worksheet, where we talk about your asymptotes, holes, intercepts, domain and range. And we'll also talk about graphing a couple of these as well. We won't actually deep dive into the graphing portion itself. We'll save that for another video, should we need it. So let's take a look at your vertical asymptote. Well, actually, we might want to start with your holes first. The reason why is if we have a hole in your graph, that is going to disrupt whether or not we have a vertical asymptote. So a hole is anywhere we end up canceling items out. So in our first one, right, this is already in your factored form. And if nothing cancels out, because keep in mind, they have to have the same exact binomial on top as they do on the bottom. Now, because these will not cancel because they don't match, we will not have a hole. So let's take a look at now your vertical asymptotes. Because nothing canceled and we still have something in your denominator provides us with your vertical asymptote. So we take your denominator, set it equal to 0, so x is equal to 7. And because we do not want this to happen, right, when we add the 7 over, right, this is your vertical asymptote. It just means that if you put in a 7 into your equation, it comes out with a 0 in the denominator. We don't want that to happen. So your denominator here is going to provide us with any sort of vertical asymptotes. Now, these are going to be lines, dotted lines, that your graph is going to approach but not touch. Now, when it comes to your horizontal asymptote, we want to take a look at the degree of your numerator and denominator. So in our case, the degree of your numerator, and I'll just pick out my 2x over x, right? These both have matching degrees. Now, when they are matching degrees, we get to take a look at your coefficients, your leading coefficients. So the leading coefficient here is 2 over 1, or just 2. So this is where y is equal to 2. This is your horizontal asymptote. Now, horizontal asymptotes, as long as they are between two vertical asymptotes, we can actually go ahead and cross those horizontal asymptotes. But if your vertical asymptote, if these are approaching your infinities on either end of your graph, we are not going to be crossing your horizontal. So just be aware, if you are crossing your horizontal asymptote, it has to be between two vertical asymptotes. Now, when it comes to your x-intercepts, if your vertical asymptotes are found in your denominators, the numerator provides us with your x-intercepts, your solutions. So we're going to take 2x minus 1 and set it equal to 0 and find that x is equal to 1/2. This is your x-intercept here. And again, we always want to start off with your hole to see if anything cancels. And if it does, that's not going to consider your x-intercept either. Now, for your y-intercept, we're going to set your function equal to, your function x is equal to 0. So we're going to substitute a 0 in for here. So you have 2 times 0 minus 1 over 0 plus 7. I think it was plus 7. Nope, minus 7. So we have negative 1 over 7. Therefore, your y is 1/7. So sorry, there's a double negative that will make it positive. And that is Leslie. Yep, done. So when it talks about your domain here, your domain, we need two things. We need your vertical asymptote, of which x is equal to 7, and your hole, which we have none. So if we were to draw a quick diagram right here, 7 is your vertical asymptote, which we cannot be. So your x values are going to expand on either side, and it's just going to skip over 7. And on either side, they're going to go approach your infinities. So from the left, we're going to go from negative infinity all the way to 7. Union, meaning we're going to jump over your 7 and go to infinity. Your range, we need your horizontal asymptote, of which we have y is equal to 2, and your hole, again, of which we have none. So if we were to draw a really quick picture, this being 2, and on either side, we're approaching your infinities here. Again, we're going to be going from negative infinity to 2, union 2 to infinity. Now, if you struggle to write it in this form or understand why, please go back to either chapter 1.1, where we talk about this particular form, or chapter 3.1, where we talk all about domain restrictions. It's also all over chapter 1.4 and again in 1.9. So if that makes sense, awesome. Pause the video and try out the rest. Now, if you need a little bit of work, that's all right. Let's take a look here. When we're looking at your first one or your next one, notice that the difference between this first variation and the second is that this second one is not already factored. So let's go ahead and factor the top and the bottom. So you have x and then x plus 5 over here. We have x plus 5 and x plus 2. And notice that these two are going to cancel. The second they cancel, we have made a whole. So your whole, this is when x minus, or sorry, it was x plus 5 got canceled. So we'll set it equal to 0. And this is where x is equal to negative 5. Now, if we want to find a coordinate, right now we have negative 5, comma, what is your y value? How do we get your y value? Well, we go and plug it all the way back in. We can plug it into the reduced equation. So x over x plus 2. So if we plug in a negative 5 over negative 5 plus 2 is negative 5 over negative 3. So it's at 5 over 3. So your y value here is at 5 over 3. So find the canceled term. And then plug in x into reduced form or your simplified form. So now let's take a look at your vertical asymptotes. And if that's all you needed, and then you want to pause the video and try the rest out on your own, please do so. Your vertical asymptote here is from your denominator, just like this one was from your denominator. We set it equal to 0, so x is equal to negative 2 here. Horizontal asymptote, again, is going to come from the degree of your numerator and your denominator. And if we take a look at your original one, x squared over x squared, we'll notice that those degree matches. So we're looking at your leading coefficient. So y here is equal to 1. When it's your x-intercept, this is coming from your numerator. So numerator is your x-intercept. Denominator is your vertical asymptote. So your x-intercept here is just equal to 0. So 0, 0, which also happens to be your y-intercept. When it comes to your domain, where you need your vertical asymptote, which we said x is equal to negative 2. And we need your whole, which we said x is equal to negative 5. So let's go ahead and put that onto a number line. We have negative 5, we have 2. These are values that we cannot be in your function because they'll cause an issue. So trying to skip over these numbers. So we go from negative infinity to negative 5, union, negative 5 to 2, union to infinity. Oh, sorry, these are negative 2s, I should say. When it comes to your range, we need your horizontal asymptote, of which we have y is equal to 1. And your whole, we need the y value, which is 5 over 3. So again, putting this into your, just like a very generic form, 5 over 3, open, open, and negative infinity, positive infinity. So we go from negative infinity to 1, union, 1 to 5/3, union, 5/3 to infinity. See if you can now pause the video and try out the remaining ones on your own. If there's any difference to it, which I think there is a difference in your horizontal asymptote, I'll definitely talk through that. But otherwise, I'm just going to be kind of repeating this process. So first thing we need to factor, we have x minus 4, x minus 3, we have x minus 3, and x plus 3. So we've canceled them. We've created a hole at x minus 3. So at x is equal to 3. So you have 3. And now we need to plug it into your simplified form. X minus 4 over x plus 3. So x minus 4 over x plus 3. We're going to enter in a 3 minus 4, 3 plus 3. So that's 6 over negative 1. So we have negative 1/6. That is where your hole is. Because I'm going to need that over here, we have your hole at x is equal to 3. And the hole for your y value, y is equal to negative 1/6. Now your vertical asymptote, we have x plus 3 in the denominator. So you have x is equal to now negative 3. Your horizontal asymptote, we have x squared over x squared. So that is really still 1 over 1. So again, these are coming from your leading coefficients. So y is equal to 1. X intercepts, this is where we have your numerator. So x minus 4 is equal to 0. So x is equal to 4. 4, 0. And your y-intercept is just by plugging in a 0 into your simplified form or your original form. It doesn't matter. So 0 plus 3. So we have negative 4/3. So 0, negative 4/3. Your domain, we need your horizontal, your vertical. Your range, we need your horizontal asymptote, vertical asymptote. X is equal to 3. Your vertical asymptote, vertical, let's see, sorry, horizontal. Oh, that's y is equal to 1. So from negative infinity to negative 3, union negative 3 to 3, union 3 to infinity. And again, negative infinity to negative 1/6, union negative 1/6 to 1, and 1 to infinity. And repeating it one more time. For factoring, we should get 2x minus 1 and x plus 3 all over x plus 3. So again, we've canceled, we've created a hole when x plus 3 is equal to 0. So at x is equal to negative 3. So you have negative 3, and we need to find your y. Excuse me. So when we've simplified, we now get 2x minus 1. So we're going to enter that negative 3 into what was left over. So that's negative 6 minus 1, which is negative 7. So this is your hole at negative 7. And again, I'm going to put that in your domain here. We got your hole. The hole. Now when it comes to your vertical asymptote, because in your simplified form, your denominator is just 1, there's nothing in there, we're not going to have any vertical asymptote. And again, from your original, we have 2x squared over x, right? Or even from your simplified, it doesn't matter, right? We are not going to have a horizontal, because when you're top heavy, when your numerator is greater than your denominator, right? So this cancels, you're just left with 2x, right? If it's top heavy, you will not have a vertical or a horizontal asymptote. Now, if it's bottom heavy, so far we've just talked about when they're the same, when they're top heavy, but let's say it's bottom heavy. So if you have more x's on the bottom than you do on the top, then this is where y is equal to 0 is your vertical or your horizontal asymptote. So when it comes to your x-intercept, well, this is where we just get to set, again, whatever is left over equal to 0. So we got 1/2 comma 0. And for your y-intercept, 2 comma 0 minus 1 is equal to 0, not equal to 0, is equal to -1. We have 0, -1. Now, because we don't have a vertical asymptote or a horizontal asymptote, and it's just the hole that we have to avoid, our restriction is going to be a little bit less. We don't have so many chunks to include. Instead, we're just skipping over the hole. I am a huge fan of this worksheet. Whoever made it, I thought was awesome. It gives us all of the stuff in a nice orderly fashion. Now, when it comes to matching the equation of your rational function, I really, really like this equation or these problems because it's already graphed it. It's given you a visual idea of what these are. So you just need to apply what we just did and now actually produce what the graph is going to look like. So I'll look at this first one. So we'll factor the bottom. So we have -4 and x plus 1. So because nothing cancels, we're not going to have a hole. So if I'm looking at it, right, these two both have a hole, which means I'm at this third one, I am at C. So this one would be C. And I could double check my answer because I'm going to have a vertical asymptote when x is equal to 4 and when x is equal to -1. Something where we have here. And just be aware, these are going up by 2. So that means in the middle here is -1. And then you have your vertical asymptote here. Now let's take a look at this next one. When we factor it, we get x plus 4 and x minus 1, or x plus 1, so sorry. We've canceled, so we have a hole. You got your leftover bit. So your hole is when x is equal to -4, and you have a vertical asymptote when x is equal to -1. So of those two features in your graph, we have two graphs left. Which one is it going to be? Well, it's going to be B. It's going to be this one. And the last one that we have x plus 4 and the x over here. So again, we've created a hole at x is equal to -4. We have the leftover bit of x, right? Well, this is just a line with a hole at -4. So y is equal to x is a line with a hole. So this is A. I really, 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 really love this worksheet. Now let's have you guys create your own function. So given the equation, right, we want to create your own function. So if I'm looking at this first one, right, notice that the special feature here, we have a hole. Where do we think this hole is? Well, the hole is when x is equal to, when x is equal to 3, which means in order for us to have a hole, if we were to work backwards, we're going to have something on top as we do on the bottom, meaning that to go backwards, we're going to subtract the 3 to both sides. So x minus 3 is equal to 0. This is what we put in your parentheses. This is where your hole is going to lie. So in order for these to cancel, right, your leftover bit has to be the line, this line. So can you create an equation of this line? Again, these values are going up by 2s, right? So your line here, y is equal to, excuse me, oh, actually even better, right? Even better with your line, actually I'll keep that part, right? Where's your x-intercept? Your x-intercept comes from right? The numerator. So in your numerator, we should get, if this is 2 comma 0, right? This 2, this is when x is equal to 2. Working backwards, subtract 2, x minus 2 is equal to 0. This is what goes up here. X minus 2, x minus 3, x minus 3, right? So, oh, sorry, this is at -2, so we need to add the 2 here. Going a little too fast here. So we should have your x-intercept at x plus 2, or x plus 2 on top in order to get your -2 over here. And again, this should be the equation of your line. This is going up 1 over 1, or up 2 over 2, which is 2 over 2, which is 1. So slope of this line is 2, and your line here is y is equal to x plus 2. Funnily enough, that's the same one over here. See if we can try it again with this one. So again, we got -2 here. This is where your hole is. So you got a hole at x plus 2, x plus 2, your x-intercept here at x, sorry, at 2, 0. So that's really x minus 2. We're to create more. So for these ones, right, we need to take away, okay, so we do have a hole, assuming that this is evenly in the middle, at x is at -5. So again, to create that hole, x minus 5, x minus 5. We also have a vertical asymptote here when x is equal to -3. So that's suggesting that we have x plus 3 on the bottom. Now, do we have any sort of x-intercept? No. Do we want to check your horizontal asymptote? Well, your horizontal asymptote is when y is equal to 0. So this would suggest that we are bottom heavy. So if we cancel these out, we have 1 over x plus 3. So we have an x left over on the bottom, which means we should have the horizontal asymptote at x or y is equal to 0. If we pause the video and try it again over here, we should, what looks like, have a hole around x plus 4 over here. So x plus 4 is on top, x plus 4 is on the bottom. We have vertical asymptote at x minus 4. Right? If x is equal to 4, sign change. So that should remain on the bottom. We also have a horizontal asymptote at y equals 0. So we should be bottom heavy. So after we cancel, we should have 1 over this value. So we have some leftover bits. And if we wanted to as well, another check that we could perform is your y-intercept. And it's pretty small. So if we get this to cancel, we get 1 over x minus 4. We plug in a 0 for your x in order to find your y-intercept. We're left with 1 over, this should be -4. Something happened here. We'll take a look. Oh, actually, looks like the horizontal asymptote isn't quite at, oh, I've just discovered that there is a little, oh no, that's my line. Never mind. Oh, yeah, the last thing we need to figure out is because, oh, there's going to be a reflection. So typically, right, 1 over x should look like it diverges this way from chapter 1.4, or sorry, 3.4, right? But notice that it's actually been flipped. It's now going the other way. That is suggesting that for us, we actually have a negative to suggest that it has now been flipped. So if we have -1 over x minus 4, right, 0 in here, we actually get to cancel those out, and we are at positive 1/4, which that would line up if this was the halfway mark and we're a little bit underneath that. All right, so this should be the end of this video. Again, I really like this worksheet for those that are taking my course. Uh, some of these problems might be showing up again.